So now looking at hot water systems, sealed and unvented, part 2. In this part we're going to look at mainly sealed systems. There's not loads in your test about this, in fact there's very little, but it's worth being aware of it because it is the sort of type of system that's being fitted more and more often these days. So yeah, in sealed systems or unvented systems, they would be fed from the mains, from the cold supply pipe. We know that that's the name of the pipe which comes in from the mains, okay? And it would deliver hot water at high pressure. Our unvented systems are different from our open vented systems. In our open vented systems, as we've just discussed, they use cold water storage systems to allow for the expansion, and expands up through the cold feed pipe under normal working conditions. Whereas with a sealed system or an unvented system, we don't have that facility, so we need to allow for the expansion in a different way. And we do that through the use of expansion vessels and through pressure relief pipework if in the case of a fault, essentially. Okay. So we need to make sure we also, because they're connected to the mains, we need to be a little bit more careful with regards to backflow prevention, because normally in an open vented system we've got the air gap between the float valve and the overflow, and that gives us appropriate backflow prevention to protect that system. Whereas within a sealed system that is connected straight into the mains, we need to make sure we fit a single check valve, because the water's heated in here, which changes it from category 1 water to category 2 water. Okay. So yeah, it's connected directly to the main, so we need to make sure we have appropriate backflow prevention, and we also need to make sure that it's safe as well. Unvented systems can be potentially dangerous, and we're going to talk about the reason for that soon. Okay, you actually need a special qualification to install any unvented system that has a capacity greater than 15 litres, because it can be potentially dangerous. Right, a sealed combi boilers, combination boilers, are actually going to be considered a sealed system or an unvented system. Essentially, they've got expansion vessel built into them, inside them, and they'll also have a sort of pressure relief valve fitted on them as well. So if the system sort of overpressurises, it can vent, and it allows for expansion as well with the expansion vessel. Okay, because they don't store. Generally speaking, they don't store water. You can get some which store will store a small amount of water to help ensure you get a sort of better flow rate. But generally speaking, combi boilers don't store water, so therefore they're not covered by the requirements of Part G, because, like I say, even though they're sealed system, they don't store that water. So you don't need an extra qualification. You would need, obviously, an appropriate gas qualification if you're going to fit a gas boiler. Okay, but you wouldn't need an unvetted qualification to fit a combi boiler, because it would store less than 15 litres, and generally speaking, they don't store any water in them. Okay. So hot water supply pipe, as we know, a supply pipe would be delivering water at high pressure, so therefore the water from a sealed system or an unvented system would be the pipework that's supplied from would be described as the hot water supply pipe. It's going to be a minimum size of 15 mil, and that you could run that at 15 mil into a bath, and you would from a combi boiler, from a small combi boiler, because the flow rates aren't that great. So if you're running a supply to a bath from a sealed system, you could use a minimum of 15 mil to all appliances. It's higher pressure. Pipework from a combi boiler, yeah, like I say, it's described as a supply pipe because it contains high pressure hot water. And the minimum size for this is 15 mil. So we're going to look at sort of controlling the temperature and safety. Okay, all system types must have a cylinder stat, a cylinder thermostat. Okay, which should be set between 60 and 65 degrees. It needs to be at least 60 degrees to pasteurize, to make sure the water's pasteurized essentially. Legionella bacteria dies off very, very quickly at 60 degrees, like literally within a few seconds. So if you heat the whole cylinder up to 60 degrees, it ensures that you're safe essentially. All of the water coming out of the taps is not going to contain Legionella. And it should be set at a maximum of 65 for a couple of reasons. It helps reduce sort of wastage of energy, because the hotter the water, the more heat loss is going to happen. And it also, especially in hard water areas, it reduces the likelihood or as much limescale sort of precipitating out of the water when it's heated. So the cylinder stat needs to be positioned roughly a third of the way up from the bottom of the cylinder, and that's so like all of the water in the cylinder, or the majority of the water in the cylinder, gets heated to the temperature that it's set at. On top of this cylinder stat, the control stat, on unvented systems they should also have a high energy cutout, which should be set between 80 and 85 degrees, which means that if the water in the cylinder reaches that temperature, it will send a message to the boiler and motorized valves to shut down and stop the water flowing into the hot water, the primary water, flowing to the cylinder and sort of heating it up anymore. The reason that we have to have this on an unvented system is essentially because if water's under pressure, the boiling temperature changes. So in an unvented system, you have water which is under pressure. It's not just atmospheric pressure like it would be if it was being fed from a cistern. This is going to be sort of potentially sort of 3 bar, okay, which actually means that the temperature that water will boil at will be significantly more than 100 degrees C, which meant if there was a fault and that water temperature continued to rise past 100 degrees C, then if the pressure in the cylinder dropped, for example, somebody opening the tap, the water can flow out, it causes the pressure to drop. That water potentially could then flash to steam, and the cylinder could explode. When water turns to steam, it expands 1,600 times, and that can cause some sort of serious damage, So you need to we take a lot of precautions with unvented cylinders to make sure that water temperature doesn't ever reach 100 degrees C. So in terms of accommodating expansion, like we said, open vented systems under normal working conditions, water will expand up the cold feed, okay, into the system. But we don't have that facility with our sealed systems, so we'd fit expansion vessels like this big red thing up here. Okay. The way they work inside is they've got a diaphragm inside, and they'd be pumped full of air. And as up to a set pressure, specific pressure, depending on how much water is in the system. And once they're connected onto the system, as the water heats up, the water will start to expand, and it can then expand into here, and it pushes on the diaphragm, which will then compress the air in the expansion vessel, and that allows for the water to expand. Briefly look at temperature and pressure faults. Like I say, an open vented system, if there's a temperature or pressure fault, it would expand up the cold feed. If that route's closed, it would expand through the vent pipe. Unvented systems have to use valves for this. So on here, we would have a pressure relief valve, and on here we've got a temperature pressure relief valve. I think, if I remember rightly, this valve is normally set to about 3 bar, and this one's probably set to about 9. But that's like, yeah, I'm 99% sure that's right. And if so, for example, there was a fault with this one would vent before there was a risk of this rupturing. This here is not just a pressure relief valve; it's a temperature pressure relief valve, which would also sort of start to open if the temperature in the water started to reach about 90 degrees C, and should be fully open if it reach by the time it reaches 95 degrees C. And that's to make sure that the water doesn't boil in here. And yeah, so it would allow this hot water out and allow cold water in to replace it essentially. So there's very little chance of water ever boiling in here because we've got the control stat, which should be set to about 60 at 65, a high limit stat, which should cut it off if it ever reaches 80 to 85, and then if there was a fault with that, then this would open then if the temperature sort of got up towards 90 to 95. Okay. So yeah, expansion valve fitted, allows the water out of the system if it over pressurizes, fitted here, and temperature pressure relief valve fitted here. Again, lets water out of the system in fault conditions. And both of these should discharge through a ton dish, and that's essentially to make it visible so people can see when there's a fault. And a ton dish you can see here, it's like a little connection with a hole in, so you can sort of see and hear when water's running, and you know that there's a fault with the system essentially. Alrighty, so we're going to very quickly look at a sealed hot water and heating system. You can see all the things we've just talked about here. So we've got the cold supply coming in here, single check valve to prevent backflow, expansion vessel to accommodate for expansion, and a temperature pressure relief valve in the case of a fault. Hot supply pipe coming off here delivering high pressure hot water to our outlets. Going to be a minimum of 15 mil because it's delivering water at high pressure. Again, we've got a fill and loop here to fill the heating side, because that would need to be done manually. With an open vented system, it kind of is done automatically because there's a float valve in the feed and expansion system. But we need to fill sealed systems manually, normally through a filling loop. And again, on here we've got an expansion vessel to allow for the expansion of the water in this sealed heating system. Again, we've got a primary flow and return to the boiler. Okay. There's a video here, interesting video. You guys can watch that when you access the video on eZone. Okay. And you access PowerPoint on eZone. And then once you've done that, you can do your task.